So number 84 on 5.3, number 84 on 5.3 says that we're going to evaluate a limit by recognizing it as a Riemann sum. So the limit that we've been given is the limit as n approaches infinity of 1 over n times the square root of 1 over n plus the square root of 2 over n plus the square root of 3 over n all the way up to the square root of n over n. So we were told in this problem to evaluate it by recognizing it as a Riemann sum. So just to back up, and this kind of ties into my quiz, what our Riemann sum in general says is we're taking the limit as n approaches infinity. That's the part that says we're putting an infinite number of rectangles in there. And what we're adding up is the area of rectangles. So we should have a summation because we're adding it up, and then a base times the height for each of those rectangles. Now, in general, that base is our delta x, and our height is coming from putting some generic x value into our function. Now, if my quiz went well for you, then you've probably already recently reviewed that our delta x is going to be b minus a over n. Now, in this problem, we were told that the function was defined on 0 to 1. So we were told that we've got some kind of function on the interval from 0 to 1. Since I know I'm on the interval from 0 to 1, I know that for whatever this function is, our delta x is going to look like 1 minus 0 over n, or 1 over n. So in terms of the Riemann sum we were given, that's our delta x. Now the next part that we have to figure out, so this is obviously what we're adding up. And if I look at it, each of these, the indexing variable, or the thing that's counting by 1 each time, is inside of the square root. So I've got 1, 2, 3, all the way up to n. So if I were writing this as a sum, this part here looks like the square root of I over n. And our I values are going from 1 to n. And then we've got our limit as n approaches infinity. So here, it's pretty straightforward to see what our function is if we remember that that x star, or that generic x value for the ith rectangle, in general has the formula a plus I delta x. And since our a is 0, and delta x was 1 over n, that means the x value at our ith rectangle is I over n. So I can work backwards here and say that this part is f of x. Now the whole idea in terms of evaluating this isn't that you know how to do this summation, it's that you recognize that the Riemann sum is equal to the integral. So this is equal to the integral from 0 to 1, and again, that's because they gave us the interval to start with. So the integral from 0 to 1 of our function dx, or 0 to 1, the square root of x dx. And again, that square root of x part is because in the Riemann sum, the function that we were looking at is the square root of x. Now we get to the fundamental theorem of calculus part. And the fundamental theorem of calculus says we've got to do two things. So in order to evaluate this integral, first, and I kind of look at this as a set of instructions where the integration sign and the dx say take whatever's inside, like whatever's in between those, and find the antiderivative of that function. So if that's the square root of x, then I could rewrite that to say x to the 1/2 power. And then to get the antiderivative, I'm going to add 1 to the exponent. And divide by the new exponent. That's our taking the antiderivative part. And then the second part of the fundamental theorem of calculus says I'm going to evaluate that antiderivative at each of the endpoints. So notation-wise, we put a vertical bar after we've found the antiderivative. Then I'm going to go 0 to 1. We'll plug in the 1 and subtract off plugging in the 0. So if I plug in the 1, I'd have, well, 1 to the 3/2 is 1. And dividing by 3/2 is the same as multiplying by 2/3. So I'd have 2/3 of 1 to the 3/2 minus 2/3 of 0 to the 3/2, or 2/3.